You've got to know your friends. The only trick here is that the angle we are talking about is 3 phi, okay, 3 phi. All right, so you have to keep that in mind. So what we're going to do is we're going to say 3 phi is going to be an angle such that its cosine is 1/2. Well, if you go into friends table, the cosine of 60 degrees is 1/2, and 60 degrees is pi over 3 radians. So it will be pi over 3. And on the very first day of 5.3, I told you that this can also be a solution if we add multiples of 2 pi. So if we add 2 pi, 4 pi, 6 pi, and so on, we still get answers that will satisfy the given equation. Okay? Well, that's not the only place where cosine is half. We have another place which is going to be in quadrant 4. And in quadrant 4, the solution is going to be 2 pi minus pi over 3, which is 5 pi over 3. And again, I need to add 2n pi to that. All right? So everybody okay on that? So these are the two, these are called general solutions. Okay, because it's got the n pi crap in there. Okay? I want to make sure you understand pi over 3 and 5 pi over 3 as to how we got that. Okay, so in your friends table, if you remember, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and underneath the radians, 0, pi over 6, pi over 4, pi over 3, pi over 2, sine, and cosine. So that's 0 over 2, 0, 1 over 2, 0, 2 over 2, 0, 3 over 2, 0, 4 over 2. And for cosine, it runs backwards. I'm going very quickly through this because I'm expecting you guys to know this pretty cold. If you don't, then life's going to be hard for you. Okay, so I want half for cosine, so here it is. Okay, and my angle is pi over 3 right there. Okay, that's where this pi over 3 comes from. Where does 5 pi over 3 come from? Well, cosine is positive in quadrant 1 and quadrant 4. So quadrant 4, it is pi over 3 is my reference angle. The angle that I really want is this. So it's going to be 2 pi minus pi over 3, which gives me 5 pi over 3. Hence, this solution. Okay. But notice that I don't want to solve for 3 phi. I want to solve for phi. Okay, what is phi? All right. So let me go add another sticky here. Okay. And kind of bring this down out here like that. And so now I'm going to divide by 3. So I get phi is equal to pi over 9 plus 2n pi over 3. This is still not a specific solution because if you read the requirements on this, well, I guess it doesn't say so here, but I want the answers in terms of, I think the next example does that, okay? The next example tells you that I want the answers in 0 to 2 pi. So that's what I want. I want answers in 0 to 2 pi. So this one came from 3 phi equals pi over 3. And then I have another set, okay, that's going to come from this guy here. And from there I get phi is equal to 5 pi over 9 plus 2n pi over 3. So next what I need to do is I need to take this set and set n equals 0. Then I get phi is equal to pi over 9. I set n equals 1. Get phi is equal to pi over 9 plus 2 over 3 pi. You know your fractions. So this becomes 7 over 9 times pi, or 7 pi over 9. Okay. And so I still haven't gone beyond 2 pi. So let's see if I add, what am I adding every time? I'm adding 6 pi to the top. So I can go n equals 2 and phi would be 13 pi over 9. I hope you see where the 6 pi is coming from. Okay, if I go from here to here, I've added 6 pi. Then I can add 6 pi more and I get 13 pi over 9. This is still not more than 2 pi. So if I go another 6 pi, I'm going to go over 2 pi because this is going to become 19 pi over 9. So the only 3 answers from this side are that one, and that one. And you do the same thing on this side here. So this guy would be phi when n is equal to 0. Phi is equal to 5 pi over 9. When n is equal to 1. Phi is equal to, and again I'm going to be adding 6 pi over 9 that comes from this 2/3 really. So I get 11 pi over 9. And when n is equal to 2, I get 17 pi over 9. And if I go beyond that and add 6 pi, I'm going to go over 2 pi, which is what I don't want. Okay, so these are my answers right here. Okay, and you can always check these answers by going back and plugging them into the equation, into the original equation, and making sure that they work. Okay, so you can see the complexity introduced by having multiple angles. And you know, we got like only 3 answers here, but there are certain examples where you know you can get 8 or 10 or 12 or you know some humongous number. Okay, let's do this example. I believe this is the last example. No, it's not. Okay, so 2 more examples to do. Okay, all right. Oops, let's try and get this down properly. I always seem to have a hard time controlling this. Now this one's going to have a lot of solutions, as you can see, because it's 4x, which is nasty. Okay, which is nasty. But hey, we are used to nasty stuff. We are studs. Okay. So set 4x equals 2. My first gut reaction would be to make this a cosine function, and so I get cosine 1 over cosine 4x is 2. Flip it over, and I get cosine 4x equals a half. So again, I dig into my friends table, and I get 4x equals pi over 3 plus 2n pi, or 4x equals 5 pi over 3 plus 2n pi. So I'm skipping this idea about how I go from friends table to come up with these answers here, okay? I'm hoping and expecting that you become experts at this by now, okay? I keep telling you that 3 things that you really need to know about the trig stuff is,